Hi, everyone. Good afternoon. It's 1 o'clock in South Africa and it's hot and sunny. And thank you for the opportunity. So I'll be speaking about managing data in Jakarta EE. And to briefly introduce myself, my name is Buhake Sindi. As I said earlier, as residing in South Africa, I've been a full-stack Java developer for over almost 2 decades now. And I've started a software development house called Sindi Technologies. And also I run a nonprofit DevOps for Kids South Africa. So basically, we go around to various communities trying to introduce children to coding and robotics, mostly communities where kids do not have computer schools or not affiliated with computing at all. So that's what we do. I'm a Jakarta EE ambassador as well, and also a blogger and a runner and all of that stuff. Good stuff. So if you really want to find me, you can scan the QR code, or alternatively, you can email me or find me on social media by either searching my full name or even on LinkedIn and X. You can also find me there, or send me an email. That will be fine. So I'll be breaking down my content into 6 major sections, but the first 4 major section is basically just discussing on how data was handled in the early days of Java EE, and the problems and challenges that we had that existed before then, and then how Java EE progressed and Jakarta EE progressed into isolating your data from the application, and then the repository pattern as well on currently, if you want to implement the repository pattern on Jakarta EE, and also the repository pattern in Jakarta EE in the future. So, and then I'll show you some few demos. And if you have any questions, I don't know what's the policy here, but feel free to ask any questions or post it into the chat, and somebody will alert me about those questions. Okay, so in early days of Java EE, application was monolithic, and if you had to run your Java EE application, you had to know how to configure it into specific to your application server. So like your JBoss and your Tomcat had different configuration on how to get your data sources running, how to get your EJBs running, and all of that stuff. And so that made it very difficult to migrate, for example, if you wanted to deploy it on WebC application server, for example, or WebLogic, because then you'll have to create a different configuration setup. And those days it was XML-based to actually get every component fully functional, not only in the application server, but also to interact with your application. So the typical example was EJBs. EJBs were heavily relied on interfaces like your EJB home, your EJB remote, your NTTB. That's where you would actually get your data and link it to your data source. And that would also bring its challenges, because one, you will have to write your SQL script. So if you were not very strong in SQL and you wrote complex SQL, that will also bring overhead. And also, the persistent manager was heavily linked on your EJB. So your NTTB, you had to have your EJB passivate, you destroy all of that stuff. So you it was very, it was not very flexible at all, and very hard to port it to different application servers, for instance. So your Oracle application server and your IBM WebSphere configuration and setup was totally different, and you could make, and it was very less portable, and even testing was even difficult. So you could not write a simple test case, for example. You needed to run it into a container. And yes, over the years we had Aquilium, but still, before Aquilium, it was a nightmare to actually test your EJBs. So as I said, there were limitations, mostly your separation of concerns, your data and your business logic was always integrated. Very limitation of dependency injection. Everything had to be found through a JNDI lookup, and also the reliance on XML. So your descriptors had to be well defined, otherwise your EJBs will not be identified, and you will basically be stuck into why your EJBs were not even picked up, or all of that stuff. POJOS was difficult because, like I said, to get your data, it had to be linked to your entity bean. And so you could not create simple POJOS to just get data for your business logic, and also to create a domain entity to persist to your data store. And also it was very difficult to test and mock up. So then we went to a big shift to enterprise application architecture and frameworks, such as the Spring framework. So things started to be abstracted a little bit. So use of POJOs and POJIs, so creation of plain old Java objects and interfaces, and then introducing enterprise specifications like the data access. So for those who early Java developers would write the DAOs and DTOs, data transfer objects or value objects, and then frameworks started popping up to try and create less boilerplate code and handle the persistence internally, like Ibatus and Toplink, and I don't know how to say Juke or JOOQ, and then ORMs like Hibernate also started popping up. Spring also introduced frameworks like repository patterns. So you had a lot of flavors, and that made it a challenge, because developers would say, you know what, I'm proficient in Hibernate, so I will use Hibernate. Some developers are more strong in SQL, so they would create DAOs and would optimize the databases and the SQL query. So there was lack of standardization into abstracting your data and your business logic. So, but it had its advantages, because things like DAOs will make your application portable, so you can actually abstract your data and your business logic separately. And there's some created consistent APIs, so like interface DAOs, where it had your basic CRUD operations. It was easier to test, and it fixed some various separation of concerns. What it lacked, though, was, for example, it had some learning curves, and even though I said boilerplate code, yes, because some had to learn some frameworks, and in initial learning, people would write a lot of code just to see how it works, and creating maintenance help eventually. Also, there's still limitation to its dependency injection. Lack of support for various data stores like NoSQL databases, as NoSQL like Cassandra started popping up, and Redis started becoming very popular in the market. So some started writing vendor-specific queries. So it will be difficult, for example, to run, if you have MySQL-specific queries running, to run it, for example, in an Oracle database, if certain data types of certain functions were not, was incompatible. So over time, with the advancement of Java EE and Jakarta EE and the introduction of annotations and CDI, it is much easier to isolate your data layer and your logic from the rest of the application components, especially also with the advancement of EJBs with the introduction of EJB3. So, like I said, we wanted the key aspects for that we want to tick is basically separated data access from the business logic, be able to test with your current frameworks like your JUnit, your Mojitos. Encapsulation, basically, we want to hide the details of how the data and the logic of data retrieval and storage, and encapsulate all that data access layer, have a consistent methods for across all data store for your CRUD operations, dependency injections. So your business logic shouldn't even care about what's going in. They shouldn't care about what's happening inside your data store. All it cares about is an abstract of the data access that it needs, and then also encapsulate also your ORM. So basically, as a developer, I shouldn't care whether I'm using JPA or Hibernate or Juke or Eclipse Link or all of that stuff. All I want to do is write my business operations, my data operations, and be able to have an abstract view of how to retrieve or persist my data without having to worry about how it works in the back end, or to go to that low level. So the repository pattern basically is a data access layer. And basically for data access, we use primarily interfaces and also design patterns. So for example, we can use a strategy pattern to do caching. So for example, if you're using like MicroStream for caching, you can use CDI delegate pattern as well to inject your existing repository and then store leverage using MicroStream repository to get your data if it's on the cache. So, and that's also introduced loose coupling between the data access and your applications. So this is not new. Spring Data has similar things. Spring Data supports many data stores, dependency injections, and also query methods. So you can actually annotate a query on your interfaces, and then internally, Spring will actually create a proxy methods to actually interface with your data store, depending on your repository you select. And your repository that you select is usually through the interface. For example, if you use JPA repository, it will link to your JPA, provided you specify your persistence unit on your persistence.xml, and Cassandra repository for Cassandra, and etc. And also, in current Jakarta EE, you can use, we also want to do exactly the same. So injectable through CDI inject, test using Mockito or test containers in JUnit, and also be able to encapsulate your data access layer and also the abstraction will be through interfaces. Data spike data does the exact same thing, but it supports many data sorts, only that those that are JPS centric, so there's no SQL support, and the same methodology Spring Data uses, it does as well. So you will annotate a query with your JPQR query on the query annotation, and internally it will inject a reference implementation based on your repository interface, and it will run it internally for you. So you implement you create your interface, like your user repository, you extend your CRUD repository, and then you annotate via a repository. The repository annotation will basically tell DataSpike that this is a repository, and internally it will do all the abstraction for you and reference implementation and injection for you. The custom approach, which I've done, is integrate the best of both, not to the very extreme. The fundamental rule was we didn't want to introduce another layer of abstraction of doing injection. We wanted to use the existing injection frameworks that exist on Jakarta EE. So we don't have a query interface. We can use the existing JPA and name queries. For us, it works. So we wanted to create something small and something that works and still uses existing Jakarta EE framework. So what we've designed is a domain object. So the domain object will be basically the representation of your data. And what we have is an entity, which is your superclass or your super interface in that instance, and then an identifiable entity, which basically has an ID, and then your JPA entity, which is basically a mapped superclass of all your JPA entities that will subclass it. And for those who want to create some kind of an audit, then we can have like a created timestamp and last modified timestamp and soft deleted timestamp. So as you can see, it says there's in bracket I, which is an interface, and in bracket A is basically an abstract class. And so basically your domain object, as I said, represents the application domain. And so the repository is basically responsible for persisting and creating the domain object. So you just specify your domain object to, if you want to persist, you provide the domain object. And if you want to read, you can provide like an ID, and then it will give you the domain object back. And internally, I'll show you how we actually do the mapping. So for example, this is the user object. As you can see, it's an entity, and it extends for us, for example, the base last modified timestamp. Basically, it's got the created by and the created on and the last modified on timestamp. And then generates its type string because the user ID is basically string, and it implements the last modifiable auditable. Basically, it tells you who created this entity and who last modified this entity. And so that is our domain object. And our repository basically, it's kind of a similar interface as your Spring Data or DataSpike data or the early prototype of Jakarta data. We split it into a data repository, which is a super interface, which has all the basic operation on on the provided entity. So on the generics, you see the E, which is basically stand for the entity. And then we sub-interface it with a CRUD repository, and then we sub-interfaces with specific repository. Like, for example, if you want to use JPA, we have the JPA repository, and then we have a MicroStream repository if you want to use MicroStream, and then subclasses further with Cassandra repository. And then your abstract JPA repository implements basically all the basic operations that it inherits from the JPA repository, your CRUD repository, and your data repository. And then if you are familiar with your specification pattern, it's basically what similar to JPA criteria pattern. You can also interface that, and then you can create your specification. You can say your JPA repository can also extend your specification repository, and then implement it on your abstract JPA repository to create your JPA criteria, and then your entity manager can execute it. So that's basically the structure of how we built ours. And so key component for us was we still stick to the repository interface. The repository interface. So at its core, every repository that we want to create will basically have a repository interface. For example, this is the super interface, the data repository. So it's got your count and your basic operations, your delete all and find all that every sub repository will have. And your CRUD repository will be everything that is ID based, like find by ID, exist by ID, etc. And then your user repository, as you can see, it's a interface that extends your CRUD repository. And then we have basic methods that is only specific to the user. So for example, does it exist by email address, or find the user by email address, for example, or by ID number. So that's specific. These operations will either retrieve the user domain object, or identify based on the criteria whether that user object actually exists on the data store. And then on top of that, then we create a concrete implementation of that interface. So in this case, for example, we have the base JPA repository where we extend the entity manager, and you can see already abstract the JPA repository. The abstract JPA repository has all the implementation of all the operations already for the JPA repository interface. And then the user repository basically implements the functions that is relevant, that it inherited from the user repository interface. And then we've annotated it as repository so that we know that this is basically the CDI container. When we need to inject, it knows that, this is a repository and this is a implementation that it needs to inject if it finds a user repository interface. And so, like I said, to make it injectable, we've created a repository annotation, which is a stereotype for the CDI CDI container to know that this is a CDIB. So whenever we do an inject and you specify the repository, it knows what to inject, basically. And it's basically a stereotype interface that we created. So on your business service, for example, this is a business service that we created. So where you specify user repository, because the repository is already annotated with repository annotation, the CDR container would basically inject the user repository. And this is a stateless session bean. So it will inherit the transaction management from the session bean. So the nice feature about this is it's stateless. So it can inherit the state of transaction from the business object. And boilerplate code, because all the abstract classes already implement all the basic operations, the user don't have to really worry about how to abstract everything or to re-implement everything. So if they specify additional functions on their interfaces, then yes, they'll have to implement. So they'll have to have basic knowledge. For example, if they need to use JPA, they will have to inject JPA. And so if they know, and if they know MicroStream, we give them a persister so they can, well, basically we don't give a persister. We give them an object where they can persist an object to, and they can just say store, and it will store it. And then entity association. For example, the JPA repository is targeting linked to the JPA entity. It makes persistence easier, and it knows already. It doesn't really know, but it can actually, but make it that strong association. You don't make that mistake of, for example, if you have a Cassandra domain object to try and persist it into a JPA repository, because yeah, that wouldn't align actually. Testing. Testing is possible because we can actually mock the interfaces. You can actually create like a dummy interfaces and use Mockito or JUnit to actually inject and do your mock, for example. And that's basically the underlying way of how we have done it. And the advantage of this is, for example, when Jakarta EE introduces like Jakarta data, and we would like to use Jakarta data, we don't have to change much because our interfaces is already there. We can just remove the reference implementation of what we have and just annotate our interfaces automatically. It will take some time, but ultimately we've already started, so that can help. In future releases of Jakarta EE, we've already got Jakarta data, which allows applications to explore the functionality and the benefit of Jakarta EE components, such as CDI, JPA, and also introduce basic interfaces for different different data store, whether it's NoSQL, web services, or SQL, it doesn't matter. Currently, Jakarta 1.0 is still under development, and the benefit of it will increase productivity because the common-based operation like the CRUD operation already exists. Optimize integration, and also define repositories. So the release will support Jakarta EE 11, and the specification, the master specification is available and is online for you if you want to read and figure out already how it works. And the features, you will have the repository interface similar to DataSpark data. Your repository interface will basically, annotating your repository interface with the repository would automatically detect that this is a repository. Query will be the query based on the data store that you use. So if you use JPA, your JPA query would exist there. And then you have three new annotation, your insert, update, and delete. Your insert will say this operation does an insert, this operation, the update will do an update, and the delete will do a delete. And the lifecycle is basically your lifecycle of domain objects. For example, in JPF, we have something similar, like you have a pre-persist and a pre-update and a pro-persist and a pro-update. Lifecycle will be like that. Stateless repository as well. The benefit of that, you can inherit the state of your business and your business services, and then your built-in interfaces. Basically, the built-in interfaces and reference implementation will be done by the container, basically. So you don't need to implement your interfaces. And you can currently run the beta of Jakarta data on OpenLiberty. The current version is 23, and just include data 1.0 as a feature. And typical example, there's a repository here that I've done, which extends the CRUD repository that's from Jakarta data. And then you can say, found by email address, and then your query is basically your query that is your JPQR query. And then the question mark one will basically says the first parameter from your method. And there's no reference implementation that comes already from the container. Okay, so demo, still got time. So I have, wait, hold on. I don't know if you can see, can you guys see the IDE or yes, no? Or the presentation? Or, okay, cool. So, why is this? Okay, so this is Jakarta Data's user repository, which I've also done, but I can also show you there's user repository here. So this is my custom one, which extends the JPA repository, because the JPA repository has a file reference by ID. The file reference by ID basically gives me the proxy version of the domain object from the entity manager. And so the CRUD repository, as I've shown earlier, and the data repository, all of that sits into the Sindi data module that we've created. And the Sindi data has so there's all the entity, and most of them are all interfaces. Like this is your entity interface, which he says is new. Just to basically identify it. Your identifiable entity allows us to do compare to just basic stuff, and your JPA entity basically just implements it is new. But on top of that, we put orders on everything. So if, for example, we have a user object, user, and it has a last modifiable. So it implements, you basically put all your JPA specific fields over there, but your abstract classes have already implemented things that are specific to your application. So your last modifiable and your created last modifiable. So we can go up, and you can see this is a map superclass, and it's got your entity listener specific to JPA. So this is basically a sanity check to say, do you have the field that's necessary before we pre-persist? For example, like this is on pre-update, we need to check that the fields that we need for update exist. For pre-persist, we must make sure that the created by, if it's a created updatable, do you have a user for the created by? So it just does the validation, basically. So we have a working example for it already. So for example, our quasi billing application, for example, there's a service. If I take a simple service, for example, like HP user service, this is basically, this is an implementation of the HP user service. All of these things are injectable, and the container basically injects this for us. And you can see, for example, the bank repository has its reference implementation, bank repository JPA, and it just says, give me all the active banks that's stored into your repository. And Control Shift, startups, and startup service basically pre-populates my bank repository. So here, for example, I've populated all the existing banks, all the existing bank accounts, all the existing medical conditions, professions, and medical specialties. So this can be seen, for example, when we register a new person. Here, your specialties are already loaded on your registration service. So basically, if I open Control Shift T, registration. We service. No, so your presentations. So on your registration, you'll see all the services are injected here. So you don't have to worry about, it's very abstract, so you don't need to worry about which repository it is using. And then on post construct, it basically loads all your active subdivision, medical specialties, and all of that stuff. And all of these things are populated here. So I can do a simple, if I log in, for example, so you can see every flow is working properly. This is running Open Liberty currently. It's deployed in Open Liberty. And the database is a Docker service, is sitting in Docker on Postgres. And this is just one feature of how we've actually abstracted ours using the custom approach that we've done. And everything works as is, and you can log in and log out without actually any hassles. Where is this? Oh, I still need, okay, I haven't logged in yet. So I also need to leave. So for example, as you log in and log out, it actually gives you an audit of your user login and log out. And that's basically the custom approach. If you want to run it on the Jakarta way, Let me see if I can stay on. Yeah, the Jakarta way will be, I need to kill this quickly. And as well, I have a microstream version. Microstream. The same approach I've done for the microstream as well. Here is your data root, basically for microstream, and all the reference implementation I've done already. All you have to do is, if you want specific to your project, the reason I've only said abstract method to get a persister, because if you want to use CDI, you want to inject your embedded storage, you can do that. And if you want to create something similar and pass the persister, you can, on your sub class, you can just extend your abstract microstream repository and basically just implement this constructor and then pass the persister, or do something similar to this. So we've just made it base so that whatever kind of implementation you want to use later, whether standalone or CDI managed, you can actually subclass it and do it your own way. But all the basic CAD operations are already implemented, so you don't have to stress about the reference implementation. And okay, so the thing is still starting up, and I'm running out of time. Let's see if it gets there. That didn't run. In the meantime, if you have any questions, feel free to ask while this thing is trying to run. Here we go. Okay, so okay, so here's my microservice that's using Jakarta data. So if you want to, we can say, for example, count all users, try it out, execute. It should give me a value of 0, a total of 0. And if I say create host. If I try it out, username first, yeah, it's fine. Um, 9.8. Let me say that. So it's give me a 201, which means it exists. And then if I say, for example, get, and then I say username, try it out, test, it should return my details. So basically, it returns my details. And basically, all I've done is my user service. This is my microservice. My user service has only, this is implementation of my user service, a stateless session B, and my user repository is Jakarta, has no reference implementation. It's just an interface. So it's basically an interface with repository. There's no reference implementation, and Jakarta data uses my JPA and is knows already how to fill it in and repopulate. So that's basically Jakarta data that's coming soon in Jakarta EE. And yeah, that's basically that. So if there's nothing else, there's questions. I'm audience. Oh, wait, hold on, there's two. Okay. Yeah, thank you.